Hey everyone, just a quick video here to talk about parametric equations and graphs. And what we're going to do is start to take a look at parametric equations, what they look like, and then do a few things with them. First off, parametric equations look a little different from other equations because you usually have more than one associated with them. So you can see at the top of this box here it says x of t is some function in terms of t, y of t is some function in terms of t. So this is kind of your typical scenario that you would get here, where I have kind of these two functions right here, x and y. And then where x is going to move is just dependent on some t. Usually we think of t as time because that helps a little bit. And then y is some other function in terms of t. So as time increases, the x will move, the y will move, and your point in space or in the plane will move as well. So we're just going to be doing kind of these two variable ones. You can have more parameters, so I could have like an x, y, and z if I wanted to move in 3D space, or even more functions than that as well. But we're just going to stick with two for now. You can kind of think of this also as like an Etch-a-Sketch, right? Your one knob controls the x, your other knob controls the y, and your point just moves around in your Etch-a-Sketch plane dependent on how those knobs move. So sometimes that might help as well. Just think of these as kind of two function knobs that tell you where your point is going to go. The thing about parametric equations is that there is movement involved, right? Static graphs like parabolas and circles and things like that don't always tell you about movement. So that's going to be one thing that's added into parametric equations that is not in normal graphs. And this is what we call the orientation. So the orientation, right, is kind of the movement of the curve. And so that is something that we're going to want to take a look at as we go through and investigate parametric equations. So I have a few links at the bottom here. I'll have this kind of linked in the course that we're talking about, but if you're just seeing this on YouTube, you can also just kind of write those down and copy them if you want to. We'll go through like the first three, and then I'll leave the other two for you guys to investigate on your own. So this walking the line, that's going to be the first one we take a look at. And I'm going to go ahead and do this in Desmos, so I kind of have that linked up already. Right now, just how parametric equations look in Desmos is sort of like this coordinate type of thing. So I have this -4 plus 2t for both the x and the y. So this would be like an x equals -4 plus 2t, a y equals -4 plus 2t. But in Desmos, you just write it in the coordinate type of format, and you do need to use the variable t. So that tells Desmos that this is a parametric equation. And because the x and y match up, right, this is just going to look like a line, like y equals x, where the x's and y's are all the same. And you'll usually have this restriction on the parameter. So right here we have 0 to 4. You could change that if you wanted to make the line longer or shorter. You just have to change that restriction on the parameter. So I'm going to go ahead and play this. We have a few, we're going to trace out this line in a few different ways. This first one is what we call even pace. So I've just replaced the t with an a, and that gives me a point that is going to move along that curve. So this point right here is just going to kind of move along that curve according to this a. So a is kind of replacing our t as our parameter, just to tell you where exactly that point is at any given a. And it's just kind of an even type of movement, right? So I can see that moving along the line, kind of just at a steady pace right there. So this is basically that first path that we're tracing out. Now, if I wanted to trace out the path in a different way, I can add or subtract or do things to it that might change the motion. So this next one is what we call the impatient walker. So this is somebody that's kind of stuck behind this guy that's just moving at an even pace, and he keeps trying to get up on top of him and get him to hurry up, but the first guy is just not going to move any different. So this other guy keeps rushing up to try to get him to move faster, but first guy is just going to keep going like he's been going. So that's impatient walker. Notice on that, it's a totally different equation, right? So we go in and expand that out. The x is still equal to the y, but there's a whole lot more involved. There's a couple of signs and some 6 powers in there and some weird stuff that keep the movement going back and forth. So that's kind of what the signs are doing. But it's just a different way of tracing out the same path, right? So the path itself is not any different, but the way that I trace out the path is very different in that one. The last one here that we'll show is what I like to call the lion in the den. So this is going to be where I'm just moving back and forth on that line. So notice I have this 4 sine of pi a as both my x and y. So again, we're just tracing out the same line where the y equals x. And this time we're just going back and forth. So I go one direction, then I come back the other direction. Then I go one direction, and then I come back the other direction. So this is like a lion kind of pacing back and forth in his den. Just going to one side, then the other side. So again, different equations, but still tracing out the same path. So any equation that you would want to use where the x equals y would trace out part of this same line. And depending on your restrictions on your t or your a, right now we're just going 0 to 4. That would depend on exactly how much of that path you might trace out. So this is kind of the gist of parametric equations, is we're just going to trace out different paths, but the motion along those paths may differ depending on the equations we got. Let's take a look at one other one. So this is what we call parametric circles, right? So now you'll notice I have this 3 cosine t, 3 sine t. That is this circle that's right here. And then the way that's getting traced out is with this blue dot, right? So if I go and trace those out, and I'm going to go ahead and edit this a little bit. This makes it a little bit easier to see, I think. So this is, you want to find my A. How this is going to get, I'm going to hide that point. So this is just kind of this 3 cosine A, 3 sine A, right, is what we're looking at there. And if I pause it, right, you can kind of see at A is 0, right, this is where I would start when t equals 0, or A is 0. And that's going to be, according to this equation, 3 cosine of 0. Cosine of 0 is 1, so and then times the 3 gives us the 3. And then sine of 0 is 0, times the 3 is 0. So we're going to start at this point, which is 3, 0. And then as our a increases, right, cosine is going to go down, sine is going to go up. So cosine is going to go get smaller, sine is going to get bigger, which means my x is getting smaller, my y is getting bigger, till at pi over 2, right? We're kind of right here at the top on that curve, and then we can keep going around, right? If we keep going around, this is going to be over here when we get to about pi, right? Now our cosine is -1, and times the 3 gives us the -3. Sine is back at 0. So you're just tracing out your functions, right, as you kind of go around that circle over and over again for those guys. So that's kind of what you'll see. So one full circle all the way back to 2 pi just takes us back when we started. And if you want to go to 4 pi, you would just keep going around the circle again, 0 to 2 pi kind of gives you one trace of that circle. You could trace that circle out in other ways, right? So some of these other ways, if I want clockwise movement, then I can try this one. And again, I'm going to maybe make this a little bit more noticeable. So if we're doing this green curve, now instead of moving counterclockwise, I want to move clockwise. So we'll go ahead and play that one. Start back here at 0. Notice this one now is going clockwise, but that's not the only change, right? This one also started at the top of the circle instead of the right side of the circle. So just by putting 3 sine A in that x coordinate, that means x is starting at 0 when A is 0, and cosine being 1 means our y is going to start at 3. So this one starts at a different place right there at the 3, 0, or 0, 3 instead of the 3, 0. And it goes a different direction, right? So this one is going clockwise. So there are different ways that you can trace out this circle, right? Just depending on where you want to start, where you want to stop, which direction you want to go, that kind of stuff. Our last one here, we'll take a look at, let me see again, we'll click that so it's a little more bold. And let's go ahead and start this at 0. So we're going to say, let's start here at 0. So this time we're starting at the bottom, right? And notice in this one I have kind of the sine of A inside of a sine and inside of a cosine. So we're going to go with this one, and this one's not even going to trace out the entire circle, right? So this is what we call a pendulum, right? So it's just kind of swinging back and forth. The sine is going to give us stuff between 0 and 2 pi, but that's going to return values, right? What comes out of the sine is just between 1 and -1, and then that goes into another sine function. So we're not getting the entire right circle on this, we're just getting a portion of the circle. And this would be kind of that pendulum movement, just moving back and forth across the bottom of that circle. Sometimes this is what you'll get. Maybe it traces out just part of a curve instead of an entire curve. And so those are important things that we want to know when we're investigating parametric equations. All right, we'll go and jump back to the other notes. And we might take a look at that walking the dog here in a minute. But I want to kind of go through a couple of these examples. So this first one is kind of what you'll usually see in terms of these problems is like sketch the curve and something called eliminate the parameter, which is find kind of that path equation, what looked like the red curve on most of our examples, just the path that it's tracing, but not necessarily the whole movement and everything. The movement we will indicate with some little arrows that indicate the orientation. So that's usually this part, sketch the curve including orientation. We'll put some arrows on there. And then the equation of the curve, when we eliminate the parameter, is just what curve has been traced out. So we'll go and go through this first one. So right now there's, I should say before we get started with that, there's basically 3 different ways that you're going to go through some of these guys. First one, right here, is solving one equation for t and then just plugging it back into the other equation. So if you can do that, that is usually a fairly easy way to go. This first one will be kind of like that. Sometimes though, you can solve for something a little larger in terms of t. So this might be like a e to the t or a cosine of t, and that expression is in the other equation as well. So you don't solve all the way down to t. You just solve until there's something that you can replace, and then go ahead and replace it. And then the third one right here is using a separate identity and kind of plugging some pieces back in. So that'll be more like this number 2 that's right there. So we'll kind of go through a couple of those. So let's start with the first one. We got x is 6t minus 4, y is 3t, and t is going to be bigger than 0, right? Sketching the curve, there's a couple of ways you can do that. One of them is basically just plotting points, right? So I could make like a XYT chart, right? So I got t, I got x, I got y, and just kind of seeing, right? If t is 0, right, where does it go? T is 1, t is 2, that sort of thing. This is usually not the best method. We'll try other stuff, but I'll go ahead and just do a couple points with this one. So usually this is fairly good if you have restrictions to find your starting and stopping point. So it's not too bad for that. So when t is 0, we're going to plug in, right? X would be 6 times 0 minus 4. So 0 minus 4 is negative 4. So I'll go and put that there for the x. The y, 3 times 0 would be 0. So that's going to be my starting point. When we plug in 1, right, x is 6 times 1, which is 6 minus 4, so that's a 2. And then the y, 3 times 1 would be a 3, so 2, 3. And then when we plug in 2, right, this would be 12 minus 4, which is 8 for the x, and 6 for the y. So there's those guys right there. So if I go ahead and draw that, I'll go ahead and do that kind of down here on this little graph. We're going to put in, let's see, we need to go all the way out to 8, 4, 5, 6, 7, 8, and all the way over to negative 4. And then we're going to also go up to, looks like 6 for my y. And we'll go ahead and plot a few of these points, right? So negative 4, 0. This is my starting value when t is 0, right? So t equals 0 starts right there. When t is 1, we get the point 2, 3. So 1, 2, 3, that's going to be right there. And then 8, 6 will be that final value. So 8, 6, that'll be right around there. So that's kind of what we're looking at for this one. So this would be, looks like I'm just doing a line. You could do more points, but those x and y values are going to get pretty big. So this is our line that we're going to get. And notice this was t is 0. This is t is 1. This is t is 2. So we would put these little arrows going this way along the curve, right? So this is just moving along that curve, going up along that line. So this is the first part, right? Sketch, include the orientation, that sort of thing. So that's one way of sketching, is just plotting points. The other way of sketching is actually doing something like part B, finding a rectangular equation for the curve. So doing a rectangular equation for the curve would be, like I said, we'll choose one of these values. If you can do number 1, usually that's the easiest, and that's probably going to be the best one for this one. So I'm going to take this y is 3t. We'll solve it for t. So when I have y is 3t, I'll just divide by 3, and we get y over 3 is my t. And then we'll plug that back in for that t in the x equation. So now we'll say x is that 6 times t, but we're going to replace that t with that y over 3. All right, so we're replacing that t with y over 3, and then we got a minus 4. All right, once I get that, then I can go ahead and simplify it a little bit. We usually want it like a recognizable rectangular equation if we can. So 3 will divide into 6, give us a 2. So now we got x is 2y minus 4. And let's go ahead and get it in the y is mx plus b type of form. So we can move the 4 to the other side. So we got x plus 4 is 2y. And then we'll divide by 2 or multiply by half, right? So 1/2 of this x plus 4 is my y. And we can go ahead and distribute that half. So we would say y is 1/2 x plus 2. Now this isn't quite the end. You do have to look at kind of your sketch as well. So looking at my sketch, we do have that line, right? We got a y-intercept 2 that I should be going through about right there. We got a slope of 1/2, so it looks like moving over 2 and going up 1 is that slope 1/2. But I'm not tracing the whole line, right? There's this whole part to the left that I'm not tracing out with this because I was restricted to t being bigger than or equal to 0. So a lot of times what they'll do with stuff like this is restrict it. So my x, right, I am tracing this line, but my x has to be bigger than or equal to -4, because I'm starting here at -4 and then just going to the right. So I would want to include that domain restriction with this equation. All right, so that's it. So this is kind of the general idea, right, with when you first start off with parametric equations, is you're just going through and putting some of those guys in, sketch the curve, right, figure out the orientation, right, eliminate the parameter, that sort of stuff. If you were trying to use some technology, I'll have a separate video for doing this on like the TI-84, that sort of thing. If you want to use Desmos, let me go ahead and talk about that a little bit, and then we'll get to, let's say, these other two, number 2 and 3, in a separate one. So I'll do those in another video. But before we leave, let's just look at this one. So I got the x is 6t minus 4, y is 3t. We'll look at that in Desmos. So let me switch over here. And we'll go ahead and go to Desmos. And like I said here, what we're going to do, maybe if I can get my keyboard to work. So we're going to put in parentheses this, I think it was 6 minus 4t. And again, you want to make sure you use that parameter t. It says add a slider, don't do that yet. And then comma, and then our y was just 3t. So 3t. And now it knows to put in that equation right there. And that doesn't quite look like what we had, so let me go ahead and double check that I got the right equation here. Let's see. Go back. 6t minus 4, not 6 minus 4t. So let me go and correct that. So we got 6t minus 4. So there we go. That looks a little bit better. And then we're going from t is 0 out to infinity. There's not really an infinity, so you can just put some large number if you want, like 100. Right, and it'll go way out there. Won't be important exactly how far it goes on this one. It just goes out really long ways. So we'll just put in a big number there instead of infinity. So this is the type of thing right here. You can't really tell the orientation. So if you want to tell the orientation, right, I could go ahead and, like I did before, just recopy that, but with another parameter like a, right? So I got 6t minus 4. I'll go back, minus 4, and then comma 3t. And, or I need an A. I was using A's. Put in A's. And then I'm going to add that slider here in a minute. So I'm going to close that parentheses, add the slider A. And now, if you want to modify the ends, right, we're going from A is 0. We'll just say up to 100. Right. And now if I play that, right, I can tell, right, there's my 0. And as A increases, I'm moving up in that direction. So I can tell, right, this graph is just going to move right up this way by using that slider. And you don't have to, let me take that pen off. You don't always have to go all the way out with your A all the way out to like 100 or something like that. That might be overkill. So let's say we just went out to 5. That should be enough to kind of double check, right, where those are. So we can see as that A value moves, exactly which direction. So starting at 0, we're at the end of that line, and then we go out further to the right. So that is the orientation of the curve. That'll do it for this time. Like I said, we'll do another one with a couple more examples of eliminating the parameter and sketching the curve. But a lot of times you will feel free to use technology to sketch, and then you might have to figure out what the orientation is. Eliminating the parameter, though, can sometimes go a slightly different way. So we'll do that in the next video.